Ladies and gentlemen, we still head back down the graphing journey, except today we start to get a peek at where this could come into some application deals, but that's coming up here in a moment. So we've discussed slope-intercept form in general already, but everything's not going to be nice like that every time. Sometimes we're going to have to deal with other information and find ways to wiggle it into the format that we want. So, first one we're going to take a peek today is, what happens when you run into an equation given point and a slope? There's a couple ways you could tackle this, but the best one-stop shopping way is going to be through something called point slope, where we're going to be plugging numbers into those three slots. This y1, x1, and m. The x and y will stay x and y all the time for this, because we're going to need those when it goes into slope-intercept form. So when you're looking at a point like this, this is x1, this is y1, not to be confused with x and y. So I just start following along, y minus, there's my y1, equals m x, now minus x1. It basically is going to change the sign on this. It doesn't mean it's going to be x minus 1 now, but if you do x minus negative 1, two minuses become a plus. So that way when I go to distribute, I'm not going to do anything screwy. So the negative 4 gets multiplied to the x and to the positive 1 over here. And then since our main goal is to get y by itself, we're going to add that 7 over to the other side and just make sure that the 7 gets added to the 4, okay, to the negative 4, excuse me, and not to the one with x. So negative 4 plus 7 is positive 3, and we are back into slope-intercept form, which is easier to graph. Now you're like, Hardy, but if we were graphing, why wouldn't I just plot the point and then go slope? I would. But if I needed to know the equation for some reason, and I might, that's the route I'm going to go. So let's play this one more time. If you are watching this on your own, and hopefully you are keeping an eye on this, you are going to want to go ahead, maybe pause me for a moment, try it yourself and come back, especially with a fraction. But if you just want to kind of roll with me, that's okay too. So all right, y minus negative 5 would be y plus 5 equals 2/3 x minus negative 6, which will become positive. And don't let the fraction mess with you. We got this. So if you're not sure on the 2/3 of 6, let me give you a hint first. 6 divided by 3 is 2. And 2 divided by 2 is 4. And 2 times 2, 2 divided by 2 is 4. Woo! Or if you're not sure and you just are looking for that little bit of help, you could always do 2/3 times 6 in the calculator and get your 4 as well. Minus that 5 over. Good to go. Okay. So now, oh boy, 2 points. These are the longest ones. So to do these, we got to do 2 steps. First, we got to do the slope formula, which, oh, I almost mixed them up. Holy moly. Subtract your y's over subtract your x's, and then roll that into point slope. I'm going to put a little note on here with that. Because sometimes we look at that and we're like, well, wait a minute. There's 2 points here. How do I know I make sure I use the right one as I'm working through here? And so as I'm looking through, I go, okay. So I look at those, I look at those. Well, I'm not going to have you do all 4 of these. That would be kind of over the top and a little bit crazy. But I do want to make sure that I see this one here in a bit. So does it matter in the long term which x is x1 and which one is x2? As long as you're consistent, not really. Okay? And I know this is going to get a little squishy, so let's do this. We're going to cross off number 5 here. We're just going to start working in here. So job 1, little slope action. So we got 7 minus 1. We've got -3 minus -6, which again would make that plus. Okay, so I've got my slope. Once I have my slope, now I'm going to go ahead and pick either point to put into point slope. It really doesn't matter this time because they both have a negative and a positive. Let's just use this one. So in this case, we're going to use -6, 1. So we're over here now. Oh my gosh, and I'm writing sideways. Okay. So y minus, there's my y1, equals m x minus x1, but minus a negative is going to make that plus. And now we're back doing what we did up above. So a little bit of distributing here. And add that 1 over. And we're good to go. Okay, so I mean, it is a process. It's like slope to point slope to slope intercept and get me where I want to go. So I'm going to attempt, we're going to see how this goes. I'm going to attempt to write really tiny here with number 7. So we're going to try the same steps again. So let me get my x1, x2, my y1, and my y2 labeled here. All right, already writing smaller. Let's see how this goes. So y2 minus y1, minus -2 makes it plus. x2 minus x1, minus a negative makes it plus. Ooh. Let's make sure I did this all right, because I think we're going to get a fraction this time. Let's see. 8 minus -2, -6 minus -2. Yep, we are. Little math on our interaction here. No worries. Okay. So we've got that set. And now, once I get that set, again, I can use either one. I'm going to use this one just so we don't get confused with the x1 and y1 thing. So, y minus, okay, here's my point. So that would be my y1 in this case, equals m x minus -6 is going to make that plus. No worries on that fraction. Watch how nice this is going to end up. We're even going to fix this up, fit this all in the box. -5 times 6 would be -30, divided by 2 would be -15. But if I don't want to do that, -5 halves times 6 is -15. There it is. And add the 8 over. And we're in business. Okay, Hardy, so why'd you start the last one? Why do we need to do that? We've already done 2. This is overkill. Hardy, we demand that you stop doing these. No, one last one. Okay, let's do this. y2 minus y1. So minus a negative makes that plus. x2 minus x1 minus a negative makes it plus. Oh. What's 0 divided by anything equal? 0, that's right. That is a wonderful thing to have happen for your slope. If you're not sure why, check this out. All right, so let's say we're going to use this point. So we're like, all right, y minus -3 makes that plus equals m x minus x1. What's 0 times anything equal? 0, Hardy, that's right. That all goes away. minus the 3 over. Okay. Now, I will mention one thing because you might get a funny little twist that comes up. I'm going to use one of my other colors here just in case. If m ends up undefined, so like you ended up with something divided by 0, x is going to equal the x value of the coordinates. Now let me explain that for a second. Check out this. These were both negative 3. Y equals negative 3. That ended up being this. If you ever see in the x values are both the same, let's say these would have both been negative 8, your equation would be x equals negative 8 because your slope would be undefined. That's a rarity, but I still like to get it out there just in case it shows up so we can get you in a good spot. Okay, now let's do a little application work here to close things up. So a cab ride costs $4 plus $1.75 per mile. We've had this discussion before. Usually the part that has the variable, the per mile, the one that has the changes value, we put that first. Could you put 4 plus 1.75x and be okay? Absolutely. Okay. X would be the number of miles driven. What would y equal then? So like, let's say I drove 10 miles. So I paid $1.75 times 10 plus 4. That number that I equal, what's that going to be? It's total cost of your trip. Okay. So once we set this up, now we can look over here and go, okay, so if Clay's destination is 17 miles away and he has $30, will he make it? I don't know. Let's see. Let's see, Clay, you're going to have to hitchhike. I don't know. I hope not. Oh, no. Clay's going to be hitchhiking or walking. I'm not sure which, but he ain't going to be riding in the cab because he does not have enough cash. Oh, Clay. Gotta think ahead. All right, let's see what else we got here. Jones purchasing a new home. The closing costs are $249 plus 3% of the purchase price of the home. You're like, okay, let's see. Closing costs are $249 no matter what. That's the plain number. 3% of the purchase price of the home. The purchase price is my x. How do we do 3% as a decimal? I'm sure somebody has figured this out at this point. Divided by 100. Okay, I got to do the 0.03 though. So here, x would be the purchase price. Y, again, is going to be the total cost. We're going to see a kind of a pattern here develop with that. So, okay, the purchase price of the home is $195,000. The offer seller $5,000 in closing cost assistance. Will this cover all their closing costs? Okay, here's where I got to be careful. I really want to put $195,000 in there, but we're going to be able to subtract $5,000 off of that. So sometimes you got to dig a little deeper to see what you're going to find here. Ooh, now let's try something. Do I want to try this? No, I'm okay. No, I'm okay. Wait a minute. Did I do something screwy? Here's what I'm pondering right now. We're going to try something. I know you love it when I do this, especially when you've written all your things already. Let's look at this one other way and see if we get the same thing. So let's say I did do it, because I have a feeling the answer is going to be a little different. So let's keep it at the 195,000 for right now. Just kind of work with me here. Gives your brain a chance, gives your hand a chance to kind of wiggle and rest for a second while I'm playing this game. Okay. So then the sellers would give me 5,000. Oh, this is going to be different. Because that would be the out-of-pocket. Whereas here, I subtracted it already. Yeah, we need to go this route. If you need to pause me for a minute, see, this again goes to show. Even Hardy can have issues sometimes with not thinking things through thoroughly. Because, yeah, you want to get the 3% and then take the 5,000, because that's a big old difference in what we're doing here. We don't want that to be the case. So that's what we're going to do. Again, pause me if we need, and we'll pop back up, because when you pop me back up, this is going to be gone in 3, 2, 1. All right. For the moment, we are going to go past 9, especially since I just made you do all that stuff there, and I don't want you to have to sit through things a whole lot longer here. Okay. Standard form. Like, wait, Hardy, standard form. Reminder. Standard form is when we have x and y on the same side of the equation and the numbers on the other. Okay? We don't have y equals. We have those together. So, Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. Okay? So, 3 bags of potting soil and 10 bags of mulch are going to equal my cost. So we got P is potting soil and M is, oh my gosh, mulch bags. I don't know what C, I mean, C is the total cost. So now I can go back in and I can be like, okay, if Josh spent $40.91 and mulch cost $2.75 a bag, how much was a bag of potting soil? I only have one variable left. And so now what I can do, okay, now we're back to good old two-step equation solving here. $4.47 for each bag of soil. Okay, not bad stuff. One last one, then we can get you down to doing a little bit of practice and being done here. All right, Kaylee has a collection of quarters and nickels. That's all they tell us. Okay, so how much is a quarter worth? So 0.45Q. And a nickel we want to make sure that people that are looking at this understand that Q stands for the number of quarters and N stands for the number of nickels, because we know what the cost is already of one, or the value, I guess I should say, of one is already. So the total is 550. Kaylee has 17 quarters. How many nickels have we got? Okay. finish her off here. Pause here for a moment because I know sometimes I get rolling, especially when I'm not talking as I go, and it can get a little crazy. But again, this is kind of letting us say, if we have bits of information, can we find out information about other stuff? That's the main part of the lesson today. Yes, there's stuff with lines. Yes, there's stuff with equations. But the biggest thing is, can you figure out, given little bits and not all the information, what the remaining info would be? So here's how we're going to kind of play with this today. We are going to be in the packet over here on page 4 over to page 5. The forms are all here. Okay. Everything is in. I think I'm going to have the answers posted on time. If not, I will have them in class for you to be able to see. So slope-intercept form, point-slope form, standard form, X and Y together on a side, plot the point and go slope. You're like, Hardy, we didn't do any actual graphing over there. Okay, I mean, I'll do one. That's fine. So 1, -6. My slope is -1/1, or down 1 and right 1. You know, get a few points going. You don't have to go crazy. That's all we got. You do not have to make the equation on those. Okay, I have you doing that enough when we get to the back of the page. This one, we're just graphing and making sure we're doing okay. When we get to the back, this is where we're going to go ahead, plug things in for point, slope, figure out what point we want, and go from there. We are scratching off number 7. I have not quite taught that in this format yet. So do not worry about number 7, but we're looking at 1 and 6. So basically page 4 and 1 through 6 on page 5. I will be back with you tomorrow.